Hello and welcome along to this climate special of the Weather Studio Live. I'm Alex Deakin and broadcasting to you live from the Met Office. This Thursday morning, it's 11 o'clock. Yes, this is a climate special. We're talking about projections for next year. The Met Office have released figures this morning about the temperature expected next year. And yes, we are anticipating that globally it will be another very warm year. Got a couple of experts lined up to come in and talk about the temperatures next year and also talk about COP, because COP is the Conference of the Parties, the United Nations Climate Change Conference. We've just had the one in Madrid. I'll be talking a little bit about that. And we're also building up to next year because that is in Glasgow. So as I say, we've got a couple of experts coming in and we want your questions. Please do send your questions in about climate. We'll try and answer them if we can during the course of the show. But even if we can't answer them, this building is full of climate experts. So we'll try and get to the bottom of your issues and your questions and maybe we'll be able to answer them at another time. But we're broadcasting live on Facebook and on YouTube and on Twitter as well. So do send in your questions if you can and we'll try and, as I say, answer them if we can today. If not, we'll get to them in the future. So this is one of perhaps the first of a few climate change specials. We're really going to be focusing a little bit more on climate in the next year, particularly with COP and ahead of that as well. So give us your feedback. Send us in your suggestions. What do you want to know about our changing climate? Now, as I said, I've got a couple of guests lined up. They're going to be talking about these global projections for next year in just a moment with Graham. We're looking forward to COP26 as well. But first of all, I'm going to talk a little bit about what's just happened in Madrid. I was fortunate enough to go to COP25 a couple of weeks ago. It ran for 2 weeks. Of course, I was there for 2 or 3 days at the start. So I'm just going to talk you through a little bit about my experiences in Madrid. And to do that, hopefully, we've got to show you a few photographs. So basically, let's set the scene. What is COP? COP stands for, as I said, Conference of the Parties. It's a United Nations climate change conference. It happens every year. It's been happening since 1995. This year was COP26, 26th in that series, and it was in Madrid. It was supposed to be in Chile, but it got switched at the last minute to be in Madrid. So this was outside the building, actually. Now, where does it take place? Well, pretty much equivalent to like the NEC in Birmingham or other conference centres across the UK. This was a picture outside, but obviously it's a pretty big deal. It takes place over a number of huge halls. There was 1 to 10 being used with, well, 2 to 10 being used, the even sides there. Big aircraft hangars of halls, and in those, an awful lot of going on. A lot of delegates there, somewhere between 27,000 and 29,000 delegates thought to attend COP25 in Madrid. And what goes on? Well, basically, in a couple of those huge conference halls, a number of nations have their own what's called pavilion. So this is the Spanish one, obviously, and each nation has their own little pavilion, their own kind of temporary structure, and within that they're showcasing what each individual nation is doing to combat climate change. So this is the Spanish one, and a few other examples. Here's the South African one. So pretty much, well, I don't know how many, was probably 50 or 60 different nations have their own little area where they're showcasing what they're doing. This is the Chilean one. I say Chile was supposed to be hosting this one, but it got switched at the last minute. Obviously, the UK had one as well, and then within each of the pavilions, often there's talks going on. So I've got a show here, a picture here of a presentation done by our very own Professor Jason Lowe there from the Met Office, and this is Professor Richard Betts as well. So they were giving a talk to delegates about what we do here at the Met Office and how we work with the government to advise on climate change, and so that policymakers are better informed about the very latest science. So this is just one example of one pavilion and one talk going on. These talks are happening pretty much every hour. So that's the pavilions. But equally, also, there's side events going on. So there's other big halls where there's enough for 200 people, and there's press conferences going on. So this is an example of press conference, Friends of the Earth press conference here, talking about what they're doing and their biggest concerns over climate change and inviting questions from the audience. But climate change, and Friends of the Earth rather, just one example. Again, there was the IPCC were there, the WMO were there, The WHO were there as well. And then this is really where the action happens. So this is what's called the plenary hall. You can see big screens up there. You can hopefully see the panel there in the distance. And this is where the really hardcore negotiations take place. These are all the delegates. You might just be able to pick out there the different names on the benches there. So basically each nation has a representation here. They've got little microphones that they can ask questions. You can also see that there are other organisations. So UNESCO are there, UNCDF are there, ComSec, all these NGOs are also non-government organisations are there, as well as representatives from the government. And this is where the negotiations take place. Now, I was only there really for the first week. The second week, and that's where these negotiations really ramped up. And of course, there was lots of ongoing discussions, ultimately ending in a lot of people's opinions in a bit of disappointment, because there wasn't really that much concrete that came out of COP25, and a lot of it has been pushed forward to next year, which will be in Glasgow, and COP26, as we'll talk in a moment with Elsa. So that was my broad overview of COP, of what happens at Conference of the Parties. That was Madrid, that was COP25. Right. That's enough discussion about that. As I say, we'll look forward to COP26 in just a moment. But first of all, let's bring in our first guest of the day, Graham Madge. Welcome. Come on in.
You made it back from Madrid, okay?
Thank you
Lovely
very much,
to hear.
Yes. Thanks for coming on. You're not here to talk about COP. You're here to talk about global temperatures. You've been on the Weather Studio Live before, but just briefly, you're wearing your climate hat today because you're a bit of a climate expert. Just briefly describe what you do here, what your role is at the Met Office.
So my role here, Alex, is climate spokesman and senior lead in the press team for climate. And as you said in your introduction, it's going to be an amazing year for climate next year, obviously building all that effort and emphasis towards Glasgow, the finale of our year on climate, if you like. What I'd like to talk about today is the fact that the Met Office just today has issued the forecast, the global forecast for 2020. And what we're saying in that is that it is likely to be another very warm year, beginning with that trend that was started in 2015 when we had the first time that the global temperature went above 1 degrees relative to that period around the pre-industrial period. So it's important to reference that.
Let's take a look at some of the headline stats, because this press release that we've issued this morning about the projections, the global temperature projections for next year, and these are some of the headline figures from it.
So we can see that the projections show that it's likely to be around 1.1 degrees above average. So we're actually getting above the levels that we've seen over the last 5 years.
That's the pre-industrial average.
Important to mention, I think here, Alex, is that this, as far as we can determine, next year is a business as normal year. When we started the series in 2015, we came off the back of that immense El Niño in the tropical Pacific, which released all of that heat from the ocean into the atmosphere. And obviously, as you would expect, that caused global temperatures to spike a bit. But what we're seeing now, worryingly, in what could be described as a business as usual year, we're actually seeing these temperatures get to this level above pre-industrial period. So that's quite staggering. And it's showing that there's no sign of that series being broken. So from 2015 up to including 2020, that will be a 6-year run of temperatures where they've been either at 1 or around 1 or well above 1 is the case, we think, next year.
How are we generating these figures? Where are these figures coming from? It's a Met Office.
So this is a Met Office product, and what our science team does is they look at the whole range of global drivers. So they're looking at the output of energy from the sun. They're looking at the potential of another El Niño. They're looking at the impact of aerosols in the atmosphere that can influence the temperature. And of course, the big thing that we're looking for is that year-on-year rise of carbon dioxide emissions. And that is the main forcing, to use the technical climate term, for what is adjusting our climate. And it's the rise in greenhouse gases, and that is standing out quite clear, as I've just said, in a business as usual year. The one thing that's continually changing is those figures keep on rising.
So we would like to be below 2016 because that was the hottest year, I reckon. That was influenced by El Niño. But we're still expected, despite this business as usual in terms of no El Niño, it's still likely to be in the top 5 hottest years on record.
Absolutely, and we can go back a little bit on the record. So looking at the figures, 10 years, the top 10 hottest years in that span from 1850 are all now from 2005.
The top 10 over 150 years. The top 10 have all been in the last 15 years.
Indeed, and those people that know their climate will know that 1998 was a major El Niño year, and what our figures show is that figures since then, the average rises have been now above that, so that's eclipsed that, and that's now dropping down the rankings, even though at the time it was a record-breaking year. Now,
people look at that and say 1.1, that's not a huge amount, but it really is, isn't it? Relative across the whole globe, across the whole year, that is a big jump.
I think that's right. I mean, you'll know as a meteorologist, Alex, that you see more variation in an hour, perhaps, than you will in that global average. But there's a couple of points that are important to remember here. First of all, you've got the fact that that heat isn't necessarily spread evenly across the globe.
Right.
So if you look at land surfaces, particularly in the northern hemisphere, and especially in the Arctic, they're warming at a much faster rate. So some locations around the globe are really on the front line of climate change. So that's the first thing to remember. And secondly, you know, you've got this fact that it's all about the averages. So you've really got to just consider that it's not just about temperature. There's all of these other impacts as well. And I think we're probably going to come on to talk about some of the other impacts of climate change.
Let's take a look at some, because there's some stark graphs here. We've talked about those the last 10 years and stuff, but this really does show the global average temperature since these records going back to 1850, since pre-industrial levels, and it just really does show there really clearly how much warmer.
When you look at that spike over the last few years, you can really see that temperatures over the last decade, how much they've gone. I think 1998 is around about here, so that was still an exceptionally warm year. But the years that we're seeing now have even eclipsed that, and what was a major event. We both remember that, I'm sure.
Of course, yeah. So these, again, global average temperatures, an awful lot of data, an awful lot of numbers being crunched, but the message is pretty clear there. Well, we can drill down a little bit and not just talk about global temperatures. We've got an interesting graphic here showing how CO2 has increased in the atmosphere. A lot of people talk about the 400 parts per million. We exceeded that a few years ago. And these two graphs, one showing the CO2, the grey one, and then this orange one here showing the average temperature difference. And they're not quite the same time period.
Important to reference that. So one is from 1850, that period of pre-industrial that we've been referring to, and obviously the carbon dioxide is from 1984, but it shows the pattern. You can see a similar trend. As CO2 builds in the atmosphere, you get temperatures rising. So that makes that point very clearly, even if the starting points are slightly different.
This is showing it's not just all about temperatures either. What are we looking at here?
So very important to say that it's not about temperature. People get very hung up on temperatures, but of course, temperatures are drivers for the impacts that we'll see. So what you've got here is a graph showing sea level rise, and obviously that's showing the same or very similar trajectory that we see global temperatures rising. So as a response to
global in millimetres.
Yes, indeed, and this is a global average. And again, some places such as the southern parts of England, the figures will be a lot higher because of the isostatic shift, the fact that southern England is sinking as Scotland is rising after the Ice Age. We're still, expecting sea level rise impacts to occur.
That just keep going up, don't they?
They keep going up,
10
absolutely.
Per decade.
I mean, there's figures of, if you look towards the end of the century, of around a metre or more in some locations. That's based on worst case scenario, because obviously our climate scientists have to model for a range of different eventualities. But worst case, within the next 100 years, we could be looking at figures around that magnitude.
And again, a lot of people talk about sea level rise because that has a direct impact impact, but there's also ocean heat content. This is a really interesting graph as well, isn't it, showing how that's been rising?
Indeed, and this is one of the major drivers, of course, of sea level rise, because as the ocean heats, the volume of water expands.
Yeah, people just assume that it's ice melting, but it's not actually. It's actually the water expanding itself.
The greater part is the rise in the level caused by the warming, indeed. But obviously, as you get glaciers and other areas beginning to melt, sea ice is negative in this impact because it doesn't actually raise sea levels because it's already floating. But when you get glacial ice melting from ice sheets, Greenland for example, then the potential for sea level rise, if they start to go, is absolutely enormous.
Incredible. I'll just get some questions now, Graham, because I know you touched upon there a minute ago, and we've already had some great questions in. But Alan Whitewick on YouTube has asked, why is the Arctic warming much faster than elsewhere?
Well, there's a very simple, reasonably simple explanation for that, and that is when you have sea ice covering the Arctic Ocean, that is a white surface, so when sunlight strikes it, it's reflected back and doesn't necessarily have much impact. When you start to get pockets of that sea ice beginning to melt, it reveals the darker water underneath, and when the same ray of sunshine hits that darker water, it absorbs the heat.
Doesn't get reflected.
And then you get a feedback mechanism and you start to see these exaggerated temperatures in the Arctic, and that is one of the major drivers of that process.
Excellent, really, really well answered, great. And another question coming in, FPL Plus on Twitter. To what extent do the experts believe the extreme heat waves in Europe over the summer and in Australia right now are directly linked to climate change and or global warming? It's a pretty complicated issue there, I guess. There's a lot going on, and there will be attribution studies. Just talk about what is an attribution study first.
So an attribution study is where the scientists using the model can actually run the same weather patterns, the same events in a world where you strip out the carbon and take it back to pre-industrial levels around 280 parts per million, and then you run the same with the concentration that we have now in excess of 400 parts per million, and you can see the differences. So we did a very successful study of the 2018 heat wave. Yeah. And the attribution study for that showed that the event was 30 times more likely to have occurred with the concentration that we have in the atmosphere of CO2 now compared with 1750. And that's an important measure because as a meteorologist, Alex, you'll know that we have one of the best series of yes. temperature and other yeah. weather data going back in some cases to 1659, and we were able to spot that in the observed record, and the observed record matched the attribution study and showed that yes, indeed, in the historical record that would be the case.
And it's important that we can do that with climate models as well. It's not just about projecting forward, actually you can go back in time, can't you, and make sure that things are consistent.
Well, you can validate the models by using historic data, and there's a whole range of different things. So it's very important, obviously, to have observations and projections. But what we must remember, of course, is that the baseline is shifting. So all the observations that we've had up to the last 30 years have largely been in a climate that was pre-climate change.
And attribution studies are really useful for when we're talking to governments. We can say this is much more likely, or this is a certain percentage more likely. And that is very useful for planning.
Indeed. And we must remember that models are the best proof that we have of a changing world and the impacts that we'll inevitably face.
Excellent. N4TX on YouTube, what can you tell us about the solar minimum? Well, you touched on that earlier as well. These projections for the forecast do take into account the power of the sun.
Absolutely. So solar cycles is something that has to be included, and that does vary. But of course, what we've got now is the forcing from CO2 in the atmosphere is greater than the influence of the solar cycle. So yes, they're still relevant. We would still expect to see some influence, but in effect, the whole climate system is now being masked by what's happening with the reactions of CO2 in the atmosphere.
Great questions, by the way. Please keep them coming in. Another good one here from, hi, from Penrith Academy from Marnie. Morning. Why is it so dangerous if the temperature rises by 1 degree? P. Banfield on YouTube asking that question, actually. Actually, it goes back to what I was kind of referencing. People just look at 1 degree and think, oh, wouldn't mind an extra 1 degree on my summer temperatures in the UK. It'd be a bit nicer. But obviously, that's just one aspect. The temperature rise, and then it's the impacts and the impacts. We've never seen it rising so quickly.
Perhaps we're not the best people to answer that today. Perhaps that question should be addressed to people in Australia and say what an extra 1 degree feels like to them on top of an extreme event.
Yes, it's all about adding to those extremes, and it's the fact that nature can't necessarily cope with the rapidity of the change as well. You talk about the sea level rising, coastal erosion, but actually nature being able to cope with the rises. Yes, we've seen temperature rises before, but not at this rate. It's this rate at which we're seeing these temperatures increase that has potentially devastating effects. Another question, Aidan Fry. Will there be another stratospheric warming in 2020 in the Northern Hemisphere? Hashtag Beast from the East. That's more about weather. That's more of a question for our normal Weather Studio Live, perhaps. But at the moment, looking at records the other day, the stratosphere, the polar vortex is almost at its strongest ever recorded. So there's no sign at the moment of any sudden stratospheric warming. It is particularly strong.
Perhaps important to mention there that when you do get an event like a sudden stratospheric warming, it can still give us cold extremes.
Yes.
So during Beast from the East, we actually had the coldest spring day ever recorded in the UK. So, global warming doesn't necessarily mean that every day is going to be hot, but it's affecting the heat extremes.
That's a very good point. And of course, interestingly, perhaps sudden stratospheric warming in the southern hemisphere is impacting what's happening in Australia at the moment.
Indeed, well, it certainly
was a rare event over the Antarctic. Sudden stratospheric warming changed the weather patterns down there and led to a very dry spring, which is one of the reasons why they've had a very dry spring, why the vegetation is so dry, why they're having terrible wildfires, and that is also now contributing to the extreme heat. Fascinating stuff, Graham. Thank you very much. Do stay with us. Going to bring another guest in now. Just a reminder there on screen of how you can follow the Met Office. Hopefully, as I say, we'll be doing more and more climate stuff over the next years. So this is a reminder there that you can follow us on Twitter, on Facebook, and on YouTube as well. But our second guest has joined us, Elsa.
Hello.
Thank you very much. Elsa Burgess, again, it's your first time on the Weather Studio Live, so thank you for joining us for this climate special. Just quickly tell everyone what your role is here at the Met Office and what you do.
Yeah, of course. So I joined the Met Office back in 2012, like you, as a weather forecaster and meteorologist. I moved into climate side of things a couple of years ago, and I was a climate science communicator. So I was communicating the science that was coming out of the Met Office Hadley Centre to make it relevant and useful for governments, decision makers. And now my new role, I'm now responsible for coordinating with the relevant government departments the Met Office response to COP26 and what we're going to be doing for that.
So we're going to be talking about COP26. Now, you and I were both at COP25.
Yes.
What were your kind of takeaways from it? What did you learn? Because it was your first COP as well.
It was my first COP. It was a learning experience.
Big, isn't it?
It was huge. So as you already alluded to, the fact that Chile was meant to host it, and with a quite short notice, it moved over to Madrid. So I was really impressed with the fact that Madrid or Spain managed to organise it in 4 weeks. It was really impressive. And then also, it was a really lively atmosphere. So it has about 27,000 delegates, I think, that attended. And it was a really great opportunity to meet people from environmental NGOs, businesses, industry, and actually just having a conversation with them, seeing what they're up to, what their perspectives are on different climate aspects as well. So yeah, I thought it was really good.
Excellent. And you were there also as a kind of a fact-finding as well, but because you're going to be, your job for the next 12 months, you're basically going to be living and breathing COP26, which is in Glasgow. So let's just remind ourselves about that. COP26, 26th occurrence of this Conference of the Parties in Glasgow in November next year. What will you be doing for the next year in the build-up to this, and why is it important to the Met Office?
So COP26 is really important. It marks 5 years from the Paris Agreement. So COP21 back in 2015 was the most substantial COP in which 196 parties ratified and agreed.
It was the first time there'd been a legally binding agreement at COP, wasn't it?
Yeah, to legally binding agreement to limit global warming to 2 degrees, with the focus to really limit it to 1.5 degrees. So it's 5 years from that, back in COP26. Also with COP26 there's more focus, so some of the Madrid negotiations, as you already mentioned, didn't go as well as expected. Still about driving that ambition as well. So what will be happening on top of what was already expected with COP26 is to hopefully ratify the Paris rulebook. So that's...
So what's the Paris rulebook?
So the Paris rulebook is... Back in 2015, the country said what they were going to do to contribute to limiting the global warming. And the Paris rulebook has said about how they're going to do that. So
basically, come next year, the governments are supposed to have a watertight plan about how they're going to implement the Paris Agreement, which is the whole how is each nation going to limit global warming or do their bit to limit global warming to that ideally 1.5 degrees Celsius, and they're going to have to come up with watertight plans.
And they work together to do that.
Work together to do that. So that's the big thing, a big driver about it. And obviously it's in the UK, so that has an impact for the Met Office.
Yes, of course. So again, UK Met Office and UK science will be really, really important. We've got world-leading science, so we'll be feeding into that. We've also provided an evidence base for government and informed decisions and policy making for that, so that will feed into that system as well. Just mentioning going on from what Graham's talking about with the global temperature rise forecast for next year, the Global Carbon Project has released figures, so emissions, although we've got the Paris Agreement and we're ultimately trying to reduce emissions in the atmosphere, for 2019 and 2020 it looks like the forecast for emissions are going to rise, but fits in with global temperatures as well. So it's just really need to enhance and increase that ambition for action.
Tricky question now for you. Put your forecasting hat on. What do you think the themes coming out? Because each year there's kind of a bit of a theme with each different COP. What do you think the main themes could be with Glasgow next year? So
with COP25, obviously the main theme was the blue COP. So that was looking at the oceans. I think some of the emerging themes that were coming out of COP25 from being in attendance was biodiversity was quite high on the scale. Next year is quite important for biodiversity. So there's a similar COP. But it's COP15, so it's Conference of the Parties for the Convention on Biological Diversity. So that'll be discussing. That's happening in October next year. So I think biodiversity.
It's more than just one event.
Yeah. So it's climate change and biodiversity and how we can look at natural climate solutions.
Excellent.
Yeah.
Excellent. Fantastic. Thank you very much. Right. I'm just going to run through see if we've had any more questions. If you don't mind sticking with us, let's see if we've had any more questions coming in. Excuse me. Is global warming affecting our weather in the UK now? Well, any individual event, any individual day is not global warming, climate change is a much bigger trend. We can't just pinpoint.
Well, I think we covered that with a heat wave.
Exactly. Yes. Yeah. When there's extreme events, that's when we do an attribution study, and what you can then say is this kind of thing is more or less likely, or how much more likely it is because of human influences or because of the increase in the amount of carbon. Should we be concerned about possible tipping points for runaway heat and where we might find the details of this kind of issue? That's a great question, Matt Brown on YouTube. I just showed a picture earlier of Professor Richard Betts, who was giving a talk, and he really is an expert on tipping points. So we'll probably get him on at some point in the new year, or maybe Professor Jason Lowe to talk about tipping points, because it's really interesting.
We should get Richard on to discuss his work around the differences between 2 degrees and 4 degrees, and it's really staggering when you look at the differences on impacts between those two thresholds.
Mike Tilsley on Facebook. How many measurements do you need to take it to determine a trend? That's a bigger mathematical question, isn't it? I think you need. We do a lot. So there's incredible amounts of data that goes into these global projections. It's all run on our supercomputer, which does 14 billion. It's 14 trillion calculations per second, isn't it?
That's right.
Yes.
So
there's some staggering amount. So we do a lot of data goes into these.
My brain is struggling to process that figure.
My brain doesn't do that, man. I think the combination of all of our three brains wouldn't do that. Current NAO is weak, positive, inconclusive for early new year. Yes, that is true, Claire. Thank you for your question. Talking about the global drivers there, and that is one of the things, the NAO, which is the pressure difference across the North Atlantic, one of the drivers for our weather patterns across the UK, and that's all linked into climate change as well. Is the NAO predicting is to bring us a cold winter? Well, it is going a little bit more negative, but all the signs at the moment is that our winter months will be milder and certainly wetter. Although there is a hint next week that it could turn a little bit colder and hopefully a bit drier, because the next few days are all about the rain. Great, thank you very much for sending in all your questions. Please do keep coming in. As I said, this is the first of what will hopefully be many climate specials in the new year, so please keep up to date with the Met Office. Thank you very much for watching. Keep your questions coming in. Anything you want to know about climate, as I said, this building is full of climate scientists. If we don't know the answer directly, and we'll hopefully have more of these in the future going forward next year. I'd like to thank a very big thank you to my guests, Graham, Elsa. Thank you very much for coming on. Thank you very much for watching, and we'll see you again in the new year. Thank you.